Good day, everyone. So in today's class, we'll be looking at period, frequency, and amplitude of simple harmonic motion. These three fundamental parameters govern the rhythm and range of simple harmonic motion. At the end of the lesson, we'll be able to define these parameters, state their formulas, and use them in solving problems involving simple harmonic motion. Let's dive into this. So we're going to start with the definition of these parameters in simple harmonic motion. When we say period, what does period really mean? What does it mean when you say period? Now, period is time. The time taken for one complete oscillation to take place. Okay? Of the time taken for one cycle in simple harmonic motion to take place. For example, now, when an object is moving in a circular form, let's say, for example, this is an object. This is an object, it's a circular object, and it begins to move round, 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 and then complete a circle. Now, the time it takes it to complete that one circle is what we refer to as period. On the other hand, frequency is the number of oscillations that is made in 1 second. The same object, when it goes round, round, and if it does it like if it goes around 2 or 3 times, and it takes it 1 second to do that, then that is what we call frequency. Number of circles or number of oscillations made in 1 second. So why period is measured in seconds? Because it is time. Frequency is measured in hertz or in circle per second because it is number of circle over time. On the other hand, the amplitude is the maximum displacement from equilibrium. Okay, the maximum displacement that the object attains before it goes back to its equilibrium position. Remember, when we are talking about circle, we are not talking about the normal circle here, such as in circular motion. But in simple harmonic motion, when we say circle, it means an object moves half circle and goes back to complete the second circle. Okay, all right. So that maximum displacement that is achieved by that object is what we call amplitude, because displacement is measured in meters. All right. So I won't say that. Let's now begin to look at the formula of each of them. For period, we use capital letter T to represent our period. Capital letter T is used to represent period, and the formula for period is 2 pi over angular speed. Okay, so period is 2 pi over angular speed. It could also be you could make period to also be period equals to 1 over frequency. All right. So aside from this first one, period is also 1 over frequency. So period and frequency, they are inversely proportional to each other. So take note of this. Now, I will say this. Let's still consider this frequency now. Frequency is the number of complete oscillation in 1 second, like we said before. So by formula, it is 1 over period, okay, or period is 1 over f, and its unit is s, like we said before. And aside from that, frequency also can be equal to 2 pi, can be equal to angular velocity over 2 pi rather. Okay, that's for frequency. Okay, it will be angular velocity over 2 pi. Why period is the reverse case? Period is 2 pi over angular velocity because they are inversely proportional to each other. Okay, so why frequency is angular velocity or angular speed over 2 pi, period is 2 pi over angular velocity. Okay, that's why you have it for 1 over t here. So those are the frequency formulas that we need to know so that we can use it to solve problems. Now, amplitude on its own does not have any formula. You just have to measure it because it's just maximum displacement. The maximum displacement that have been attained. For example, now, if you normally use this sinusoidal graph to represent the motion of simple harmonic motion. So if the sinusoidal graph is like this, all right. That's the movement of the object now. Now the maximum height attained before going down is called the amplitude. We use capital A to represent it. So you have to measure it. So you cannot obtain amplitude uh, from a period or frequency. No, you can't get amplitude from frequency. You can't get it from period. You just have to what? You just have to measure it, or it will be given to you directly. All right. So I won't say that. Let's now consider period in some example of simple harmonic motion. For example, in simple pendulum, okay, the period in simple pendulum is 2 pi times square root of L over G. For single pendulum, period is 2 pi times square root of L over G. Why the L there is the length of the thread. This is a simple pendulum. Okay, the L there represents the length of the thread. Here down. Okay, this L. Of course, this is the bulb itself, the bulb of the single pendulum. Okay, this is the bulb. Now the length is this one. Okay, the G is acceleration due to gravity. Okay, it's a constant, which is 9.8 meter per second square, or 10 approximately. All right. So the 2 pi there are just numbers. Okay, the pi there represent 22/7. So in single pendulum, aside from the other formula that we have said before, that period is 2 pi over angular speed. We also said period is 1 over f. So for simple pendulum, period is also this. So take note of that. And aside from single pendulum, in spiral spring, period formula is also different here. Period formula is 2 pi times square root of m over k, where the m is the mass of the object, so that is hung on that spiral spring, and the k is the spring constant or force constant. Okay, so take note of 4 formula for period now. We've had that period is 2 pi over angular speed. We've also had it that that period is 1 over f, right? 1 over f, and we've added that period in terms of pendulum bulb is 2 pi square root of length over graph. Then in spiral spring we have this making 4 now. So period adds majorly 4 formulas uh, in simple harmonic motion. Okay. Now let's now consider some questions that involve these parameters we have talked about. So here we have a boy time 30 oscillation of a certain pendulum thrice and obtain 1 minute 10 seconds. That's the first trial. The second one is 1 minute 12 seconds, and the third one is 1 minute 7 seconds respectively. The mean period of oscillation of the pendulum is A 0.14 seconds, B 0.43 seconds, C 2.32 seconds, and D 6.97 seconds. Now, a boy time 30 oscillation. That the 30 oscillation means the number of oscillation is equal to 30. Okay, of a certain pendulum thrice, and obtain the following. So the number of these are the time it takes to complete this oscillation. Okay, so the first one we got 1 minute. Okay, so we have T1, T1 to be T1 to be. So for our T1 now, our T1, formula for period, we say it is 1 over f. Aside from that, it's also T over n. Okay, so I've brought in another formula again now. Aside from 1 over f, period is also what? T over n. T over n. Now the n there is number of oscillation, while the t there is the time. Is the time it takes to complete oscillation. So take note of this. Take note of this, that for 30 oscillation, he got this time. Okay, we got this time. All right. Now, for us to now get the average, the mean period also means average. Okay, so we have, in this case, we have T1, we have T2, and we have T3. So for us to get our average T, our average T will be T1 plus T2 plus T3 over 3. When we say mean also means average, and it will be addition of the three time divided by 3. And take note of this time, they are all in milliseconds, but our final answer is in seconds, so you have to convert it to seconds first. Okay, now for our T1, which we have it to be 1 minute, 10 seconds. Okay, so converting it to seconds means 1 minute means 60 seconds, so this one is 70 seconds. So our T2, we have 1 minute, 12 seconds. So converting to second, 1 minute is 60 seconds plus 12, that's 72 seconds, right? Then to T3, you have 1 minute, 1 minute, 7 seconds. So converting it to second, 1 minute is 60 seconds, so 60 plus 7 are 67 seconds. Okay, now since we are now finding the average of the whole time, so T there will now be this plus this plus this divided by 3. So we have 70 plus 72 plus 67 all divided by 3. Okay, and that will be equal to, let's quickly check the calculator. So 70 plus 72 plus 67. So we're having 209. So we have 209 as our numerator here. So 209 divided by 3. Now, when we divide this by 3, divided by 3, dividing this by 3, that will be giving us 69, 69.6. Okay, that's giving us 69.6. So we have it as equal to, this equal to 69.6. Okay, 69.6. Now you could see that this is the time. This is actually small letter t. It's not capital T. So take note of it. Based on that question, a boy timed 30 oscillation of a certain frequency number twice. So this t here, this time here is this small letter t here. Okay, this small letter t is the time recorded to complete 30 oscillation. But period is the time taken to complete one oscillation. So our T1 that we have used here, our T1 is actually small letter T1, okay, small letter T2, small letter T3, because we have to find mean period. Okay, now to now get our mean period, we need to first get our mean time first. So this is our mean time now. So this is also T1, T2, and T3. So take note of that. So, and this is TT. Now to not get our period itself, this particular one, it will be T over N. So don't forget. So our period formula is T over N. So this one we have gotten here is our T, which is 69.6 over N. Our N is 30. All right. So this question is very tricky. So we now go and calculate our period now. 69.6 divided by 30. So 69. So say 69.6 divided by 30. So that will give us 2.32. So 2.32 seconds, and that is our answer. There is option C, 2.32 seconds. So please take note of it. This time you see here is not period, because this is the time to complete 30 oscillation. Period is time to complete one oscillation. So it just T1, T2, T3. So the average of this time is what we have gotten to be 69.6. Period is now the time to complete one oscillation, which will be that T over N. So take note of that. All right. So our final result here is uh, is what we have up there, and that is 2.32 seconds. All right. So let's consider another question. Here, it said if in a simple pendulum experiment the length of the inextensible string is increased by a factor of 4, its period is increased by a factor of A, 4, B, uh, 1 over 4, C, no, this one is 4 over 4, C, 1 over 4, and D, 2 pi, and E, 2. So let's look at the question again. If in a simple pendulum experiment the length of the inextensible string is increased, let's say the original string is L1, is not increased by a factor of 4, but that means our L2 is equal to 4L1. So we have to now find, and the initial period is T1, so we have to find the period at this increment, so T2. Okay, that is unknown. This is dealing with the pendulum bob. I know in pendulum bob, formula for period is equal to 2 pi square root L over G. So indirectly, period is proportional to square root of L. So if you are going to form a formula with that, going to be T1 over square root of L1 is equal to T2 over square root of L2. Okay, so we have to find T2 here. So T1, uh, T1 now, T2 is what we are looking for now. So T2 there is equal to, so T2 from this formula here, making this object formula will be equal to T1 multiplied by square root of L2 over square root of L1. All right. So from there, say T1 square root of L2. L2 is 4L1. So square root of 4L1 then over square root of L1 itself. Okay. You get it now? And this can still be broken down into T1 square root of 4L1 over L1, right? So L1 cancel L1. And square root of 4 is 2. So that will be equal to 2T1. So that means the period will be increased by a factor of 2. Okay, and that is option E, 2. Okay, so let's see another question again. Here it says a simple pendulum 0.3 meter long. So here we're given L is equal to 0.6 meter long at the period of 1.5 seconds. So we have period to be 1.5 seconds. What is the period of a similar pendulum? Okay, so then this one is L1 then, and this is T1. So what is the period of a similar pendulum? That is our T2 now. Pendulum 0.4 meter long, so L2 is 0.4 meter long in the same location, just similar to the one we just finished solving. So here we can say T1 over square root of L1 is equal to T2 over square root of L2. And here we are finding T2 again, just like the first one. So we can say, let's divide the page. So from here, T2 as subject the formula will be equal to T1 square root of L2 over L1. Okay, so from here, substituting the value, our T1 is 1.5, then square root of L2 is 0.4, our L1 is 0.6. Okay, so making it forward, our T2 there will now be equal to 1.5 times the square root of 0.4, let's do 0.4 divided by 0.6. Okay, so 0.4 divided by 0.6, right? And that's giving us 0. Let's say 0.67. Okay, so we have it here to be 0.67 approximately, and that will be equal to 1.5 times. Now let us find the square root of 0.67. Square root of 0.67. So let's get the square root function with our calculator. The square root of 0.67. Okay, so when we do that, we'll be able to get our value. So square root of 0.67 square root, that will give us 0.82 approximately. So we have it here as 0.82, and we'll multiply this together, so we get our final answer to be 0.82 times 1.5, right? That will give us 1.23. Now 1.23 is the final answer here. But if we look at the option we have, there is nothing like 1.23. So what you now look out for is what is similar here. Okay, now looking at the option here, we have 1.5 square root 2 over 3, 1.5 3 over 2, and we are getting our answer to be equal to 1.23. So best thing is to confirm this. Okay, now coming back here now, you can quickly deal with this. Let's use this as our breakdown. So we have it as 1.5 square root of, this will be giving us 4 over 6 if you multiply by 10. So 2 here, 2, 2 here, 3. So that this is actually the correct answer. That would be 1.5 square root 2 over 3. And the correct answer is option A. So it's not the time you will see your final answer like this. So sometimes you have to know what have been manipulated. Multiplying the numerator and the denominator by 10, you will get 4 over 6, and simplifying it to the lowest 10, you will get 2 over 3. All right. So we are going to be doing the cutting here today. I hope you'll be able to learn something on this topic today. Thank you for listening, and bye for now.